Welcome to another exercise for the workbook Statistics, this time focusing on measures of central tendency and alternatives for calculating them. So here in this example, we have a set of pupils, or rather data for a set of pupils with regard how often, how long per day they are actively using the internet. So here we can see data for 10 pupils, and our tasks, well, first off, construct a frequency table and then calculate the mode, the median, and the arithmetic mean. So let's start with the first part. Let's start with constructing the frequency table. But before we actually get there, to make our life easier in part A and in part C, we're first going to restructure our data set. With restructuring, what I mean is we're going to take this and we're going to order this from smallest value to largest value, so in an ascending fashion. Now it looks like this. We always get the next largest value starting at 1 and finally arriving at 11. As I said, we did this for two simple reasons. We're going to use this, the next part, for the calculation of the frequency table, and we're going to use this when we calculate the median. So to build the frequency table, as I said, I'm going to refer to this ordered data set, and I'm going to make a table with 4 different columns. And in the first column, I'm going to write all the different values present in this data set. So each of these values I'm going to note only once. If I'm going to do this, I get 1, 2, 3, 4, 6, 8, 10, 11. That's all the values present in this data set. Then, in the second column, I'm going to note how often are these values represented in the data set. So in this case, I see that the 1 and the 3 are represented twice, all the other ones are just represented once. So that's the absolute frequencies. If I now want to add also relative frequencies, I can simply add up all the absolute frequencies and divide each of the absolute frequencies with the sum, giving me the relative one. So I have 10 observations here, so each of these values divided by 10 gives those values. Then finally, I'm only left with the column for the cumulated relative frequencies. So here I'm going to add up step by step all the relative frequencies. So I start with the 0.2, going to add up the next one, giving me 0.3, the next one, 0.5, the next to this one, or rather, I'm adding up all the ones above this. So here I have 0.2 plus 0.1, 0.3. Here, 0.3 plus 0.2, 0.5. Here, 0.5 plus 0.1, 0.6. Here, 0.6 plus 0.1, 0.7, and so forth. If I want to know whether I did this correctly, I can simply add up all the relative frequencies. I should end up at 1. And similarly, if I finish with the cumulated relative frequencies, the last entry should also be 1.0, rather 100%. So yeah, that's our frequency table. That's the one we're going to use next directly for the mode. So I'm just going to copy it. And if we want to calculate the mode, that's actually the entry with the largest absolute frequencies. If I take a closer look at this table, I see I have a 2 for the value 1 and I have a 2 for the value 3. So in this case, those are the 2 largest absolute frequencies. The mode would actually be 1 and 3 because they are the same regarding the frequencies. So the mode in this case would not be unique, which however in our situation doesn't matter since we consider that the mode can be 2 or more values as well. Well, that was already part B, so let's carry on with part C and the median. And for the median, we're going to use the ordered data set. That's actually the most important part where I'm going to use this one, or the ordered version thereof. So here for the median calculation, I first have to decide which of these two formulas am I going to use, because I have two different possibilities. And which of those formulas I'm using depends on, do I have an even number or an odd number of observations. Here I have 10 observations, so I have an even number of observations, meaning I'm going to use the first of those two formulas. So I have to determine the indices for the two variables, for the two values. Well, the first one with 10 observations is 5, the second one is 6, meaning I'm going to look up the 5th and the 6th observation, which here are 3 and 4. And then I'm going to calculate the average of 3 and 4, giving me as an end result 3.5. And that's my median of this data set. So in other words, if I have an even number, I'm always considering the average of the two values in the middle. Well, there was the third part of this exercise, so let's turn to the arithmetic mean. With the arithmetic mean, I have three different alternatives. For the first one, I'm still going to use the ordered data set. That's why I copied this here. And it's relatively easy using this formula, which simply means add up all the different values. That's like this part here. And once you added this up, divide it by the number of observations. That's the 1 divided by n. Practice looks like this, adding up all the values, dividing this by the number of observations, giving me as an end result 4.9. However, I have two alternative approaches which might make this calculation a bit easier, might comprise or make a bit more compact what I'm going to do here. So for the first alternative, I'm going to refer to the frequency and in particular to the column of values and absolute frequencies. I'm going to use this formula which simply reads as multiply the absolute frequencies Ni with the values Ai. So always going 2 times 1, 1 times 2, 2 times 3, 1 times 4 and so forth. And in the end, divide this by the number of observations. So if I'm going to do this, I see it becomes a bit smaller since I'm not going to write the 1 twice and the 3 twice, but I'm going to simplify, to summarize this a little bit. Well, here in this case, I have a lot of observations, a lot of values with frequencies of 1, so this alternative does not really save a lot of time. If I have more values with higher frequencies, this can significantly shorten the time of calculation. In the end, however, I will get the same 4.9 than in the version before. This also applies for our second alternative, which I'm going to explain on the next slide. Here we are again using the frequency table, but this time we're going to use the values and the relative frequencies, because that's this formula, which simply means take the relative frequencies, multiply it with the value, and do this for all of the different values and add this up. So I no longer have to divide by the number of observations in the end, but that's simply for the reason because all the relative frequencies already have been divided by the number of observations. So multiply those with these and so forth. This will at the moment look longer than the original one. That's again the situation as I mentioned before. This might help you a bit more once you have much higher absolute frequencies or relative frequencies and not only one observation for each of the values. However, in the end, again, we're getting the same result as before because it does exactly the same as the two versions before. So I would always go with, if you have very small frequencies, use the original version by simply adding up all the values. If you have larger frequencies, values which are more often occurring in your data set, then you might actually consider using one of the two alternatives. And that's more or less everything I wanted to mention in the context of this course. So I hope you enjoyed it. I say goodbye and see you next time.